Hello, welcome back to our lecture series on Cummins HSK78G genset. This is our second lecture and we'll discuss about installation guidelines and recommendations for HSK78 engine. So in our first lecture, we have gone through about technical specification, product identification, and the efficiency of HSK78. The lecture is available on playlist. So let's start our second lecture. Cummins C 2005 CDR HSK78 gas generator installation guidelines. Here we will show you a few pictures of installed genset at different locations around the globe. These two pictures are basic genset installation inside the buildings. This is an overview of enclosure installed genset, containerized genset. These are different options of cooling with radiators and cooling towers. So let's start our lecture. The first one is site preparation. Before we receive the genset, our site should be ready in well manners to receive the genset. In site preparation, the first and very important and crucial part is plinth or bed or enclosure base. The base or the plinth should be enough strong where we put the weight of the genset and it can bear the vibrations when the genset should be in operation. The recommendation is the reinforced of concrete with a 28 days compressive strength of at least 2,500 psi pressure. So these are the recommendation. Then the recommendation is your plinth is 150 mm or 6 inch inside the ground and 6 inch above the your floor level of your powerhouse, where the reinforcement that with concrete and iron parts. And if you are looking your enclosure, so your enclosure or your container should be enough strong base where you can put the genset and it must bear the weight and the vibrations during the operation. So let's look at this is the genset plinth inside the powerhouse. You can see this is about 6 inch above from the ground floor, then 6 inch deep inside the floor and reinforced with concrete. This is a typical in preparation of a container or enclosure where we have enough iron bars and huge handles or edge beams where inside the basement or inside the base, so it can bear the weight of the genset and vibration. The next crucial part is location and environment specification. This for gas engines, the specification for the environment, it should be a clean environment. And when we are looking at the installation of the genset, the recommendation is the distance between two gensets is minimum of 5 meters that allow adequate access for maintenance, cooling, air passage. Then because of some areas where we have a space constraint, so at least 2 to 3 meters should be allowable to install the genset. The atmosphere should not be dusty, and if it's dusty, then we need to arrange some filters because gas engine need fresh air for combustion. This is a practical powerhouse. You can see how it is. Then the flow, the genset to genset distance and installations. Then these are the a typical enclosure type of genset where you can see the environment is clean. Yes, we cannot say the genset cannot in dusty environment, mining those areas where the dust and all those parts are crucial. Yes, it can run, but we need to get some preliminary actions like filtration and others where we get the fresh air and clean air for combustion and cooling purpose. The third one is site preparation, that is ventilation specifications. Gas engines are enclosure with different selling inside the powerhouse or inside the enclosure. We need fresh air. for combustion and cooling. Gas engine work with 80% of air and just 20% of the gas. So we need to prepare a filtration system on the back and to fetch the fresh air from the atmosphere of the surroundings. That fresh air will take a crucial part for cooling and for combustion. If our air is not clean, if the temperature is hot, we have poor fuel efficiency, we have overheating problems, dusty environments, so it will impact on the genset efficiency. So for this purpose, we normally use the fans. That can be a selector fan or dilution fan, you can call it. The first thing is the fan, and before the fan, we try to develop a filtration system. So the dust particle and other particle just filter there. Fan will suck the fresh and clean air. Then we have the ducting system. Here we can see we have the ducting system that the basic genset are inside the building. And if it's containerized, we have the ventilation for our extractor fans. So we can achieve this ventilation system with the three different methods. Number one is the balance ventilation is at one side of the powerhouse at the inflow we are receiving, we are sucking fresh air outside the powerhouse or enclosure. Then the other side of it, we have extractor fans that can push out the hot air inside your atmosphere. We have abstraction only, where we just put the fans on extractor side that can also suction air from the one side of the enclosure and just pass it outside the hot air, something like we are diesel radiator that are mounted with the generators. They are just suction and throwing the hot air outside. So we can adopt any of the procedure, but the necessity is the air should be clean and dust free. So because the air will take participate for combustion and cooling. These three parts are for site preparation that should be prepared before we receive the engine. Now let's have a look for transportation of the genset and the lifting procedure, because it is necessary to be aware before installation how we move our engines and how we lift it for crane operation or transportation or handling purpose. I want to tell you the weight of this genset is around 23 tons. So when we are looking for a crane, it should be an adequate size that can take easily 23 tons of the genset. We have some look of documentation and the actual pictures where how hook points the legs where we put our strings to lift the engine, lifting hooks. And where next picture is the real picture when you see how it will hook in the air and book. The train should be minimum of 50 to 60 tons that can carry this engine easily. There are some cautions mentioned in the slide that make sure the vehicle is the suitable size, the crane should be suitable size, and when they put lifting the strings or lifting strap, so when they tension them to make sure none of them is suppressing any part of the genset, especially those air tubes and GIP panel, so that make sure when they lift it, it will be free from the genset. No part will be bending during the handling of the genset. Then we have some pictures of transportation. So when we are transporting, look at the genset on the vehicle, we tie them very well so that during transportation it will not move or it will not be shake. So some other pictures, other views of when the genset is on a vehicle. Let's look the first installation procedure. When we place our genset, the first thing we need to do is to install the AVMs and level the genset with the AVM. This genset has about 10 AVMs, 5 AVMs on the left side, 5 AVM on the right side. The AVM is about 6 LVM 6800. That is the model of the AVM Cummins will supply to you. These are the AVM. Then we have a washer, we have nut, and we have the bolt. So let's look at the next picture. Once the genset position, raise the genset up to AVM height. This can be achieved through monkey jacks or hydraulic jacks. Insert the AVM and tight all the AVMs. Then perform the measurement each AVM. This is the can AVM. Look at the measurements. This should be minimum at maximum. And the torque of the jam nut. So once we hand tight them, we should take the measurements. If within this range, then we use the plumb on the HDM of the genset. If it's level, we can now tight all the AVMs. This is actual picture how we place AVM. This is the ceiling cap. Once we place AVM, we cover this one with the cap, and this is the actual picture, final look after AVM and ceiling cap. These are the recommendation about the AVM. After AVM, so we look at the mechanical connections such as the cooling, exhaust, and coil. The duty of this engine, all the mechanical connections such as breather, cooling in, cooling out, and the gas inlet is located at the front side of the engine below air filter housing. Then the gas inlet is also located at the same location. Breather is also located at the same location. Then we can look at vent lines, where vent lines for cooling, LT and ST, they are located at the highest point of the genset, that is after pull-up coil. Then dew belt filling is located at the left side. Access cover, where we can fill lubar manually or auto. Then drain is also located on the left side of the genset. So let's have a look detailed on all this connection. The first thing we look at LT and HT, coolant inlet and outlet lines. If we look at the front side of the engine, below air filter housing, we can see 4 pipes. In last picture, we also mentioned LT in, LT out, ST in, ST out. So the first thing we look at those connections, we use rubber flex joints to wear the vibrations when the genset is in operation. The ST line is a 4-inch line and LT line is 3-inch line. That is DN100 and DN80 connection. This is the full diagram of the connections. Then the ST and inlet and outlet line is 4-inch DN100 or 100 mm with whole flex rubber joint. The LT line is 3-inch 75 and DN80 flanges. So from here we pick the lines to our cooling system. Cooling system depends on the area, whether it is radiator or it is cooling tower system. We also look in the coming slides. Let's look at a bit details of more LT and ST connection. The first thing is with the genset, once we do any kind of piping, we must do something flex connectors. So there are 2 types of flex connectors. One is rubber type or one is steel flex connector. You can supply either of the type, and we use them with LT and ST cooling lines and the gas line and others. Then we also use butterfly valves. It will make us ease for maintenance. If our coolant is leaking somewhere or want to change any component, we can lock the coolant one side, other engine side, or either cooling tower side or radiator side. So it's better we use the butterfly valves to lock the coolant. So during maintenance, it will make our work easy. Then it's equally better we use standards on the lines, incoming lines. So by the time when the pipes are growing old, yes, it will introduce corrosion and other particles. So when the cooling is flowing, it will go to your pump. So it's better before send it to circulation pump, separate all the particles, and for that purpose we can use a standard so that all the debris or dust will stay in the standard and the clean water will pass through the pump. That will not damage the pump impellers and others. So is another advantage of using the standard. Let's look at the expansion tanks. Expansion tanks used to regulate the coolant flow, prevent pressure buildup, and protect cooling system from damage by absorbing excess coolant due to temperature changes. To maintain coolant level, urging excess air in the system into the air. Then let's look at some different type of expansion tanks. These are different type of expansion tank. This red and gray is a pillow type. Inside they have a pillow. Then this one is the simple type. This is what Cummins used to supply is a single unit by demarcation of ST and LT size. Then on the lines for safety, we can also use some temperature and pressure gauges and overpressure switches that provide for the system safety. If we are using this bladder type red and gray type, we don't need to put them on the highest point. We can just install them with the engine on floor. So the bladder inside is a rubber that can expand, squeeze with the temperature changes and provide to adequate the cooling. Then, but if we are using these other two types, we need to install them a minimum height of 5.5 meters. So where it will give us a gravity at least 0.5 bar pressure, then to make up tank and all those things. So that's also another difference in these two types. Let's look at coolant vent lines. Coolant vent lines, I already mentioned that it should be highest point of the engine. That is aftercooler core. Aftercooler core has two circuits, LT and ST. So on the same point, we have LT and ST vent lines. All the gears and other things are produced when genset is running. So through these vent lines, it goes to make up our expansion tank where they release air in the air, and it has radiator cap that operate at 1.314 bar pressure. So these are the vent connection on the tank, those white pipes. Then this is drain and fill point of coolant that is located close to circulation pump. Look at this. This is at the coolant fill point, and that is ST fill and drain point. So we can drain coolant from these points, and we can fill coolant from this point. Apart from this, some other drain points in the block that when we want to drain full coolant, we cannot use that to drain the full coolant. But if you are doing that work next cylinder and the other changes are just to fill and drain, we can use these points to fill the coolant and drain the coolants. This is radiator. I will mention that our cooling system for the genset, where radiator can be supplied through any company, something like Alfa, Luby, and Thermax. And there are so many companies in the world, they are supplying radiators. Cummins can supply you an radiator, or you can buy your own radiator. It can be flat type, deep type. The basic function of the radiator is when our engine is running, just is produce heat. The coolant temperature get high, then it now flows to radiator. Radiator is dissipating heat generated in the atmosphere and cool down the coolant and send back to engine for circulation. So that's the basic function of the radiator, is to provide cooling to our coolant. It has fans where it will just, when the hot cooler pass through the tubes, the fan is throwing hot air in the air, and delta temperature should be around 12 to 15 degrees before down the cold or cooling coolant start coming to the engine type. Normally, the radiator designed with the circuits available on the genset. This HSK has two circuits, LT and ST. So the radiator designed with LT and ST circuits. LT circuit is for LT system that cool the aftercooler core, and ST is for the block and the aftercooler core. The radiator has the connections for the LT and ST with mention in and out. So we bring lines from engine where we did L-thickening and S-thickening. We bring lines from there to radiator, and we take cold line and return line from radiator to engine. Radiator can work mostly where we have tropical areas, where the atmosphere temperature not exceed more than 40 to 45. Radiators can work well there. But if atmosphere is like desert or hot countries or like Asian countries, African countries, where radiator will not survive. So the alternative of radiators are the cooling tower. Let's have a look on cooling tower. Before we look the cooling tower, let's look at complete circuit from engine to cooling radiators, how the pipe will through fire. This is the connection on the engine. So these are what we explained. We can put walls and standard and pressure gauges and temperature gauges. We can see all them in this picture. Then the pipe goes out and the height where we have our radiator. We can see the radiator. Then here finally where to connect the pipes to the radiator. I mentioned that radiator has in that an outlet line connection where we bring lines from the generator to radiator through in. We can install valve and standard pressure gauges and temperature. This is a complete circuit of from genset connection to radiator. How we lay the pipes are how we can arrange them. Then next, as I mentioned, that some areas where the heat is much, deserts, hot countries, cooling tower radiator will not work. What we use on those areas is cooling tower. Cooling tower can give more delta temperature as compared to radiator. So the DC function is the same. This cooling tower is also a running fan. Then it has fins both sides. Then where the hot water drops from the top, we now drop them by drop both sides. Then the fan is running and throwing the hot air or dissipated heat into the air. The countries, as I mentioned, that hot countries cannot survive. So in this cooling tower, we are using fresh water with some chemicals. But inside radiator, we are not using hot water. The coolant through out from genset to radiator. So that one is a closed circuit. So radiator to genset, the cooling is fine, that is closed circuit. But radiator is not that cooling tower is not working that way. We are running fresh water inside the cooling towers, and we use heat exchangers, plate type heat exchangers. This heat exchanger installed close to engine. So this heat exchanger has in and out of coolant and in and out of water coming from the cooling tower. So on one in and out, we connect our coolant lines from the engine, and the other in and out, we install the two lines coming from cooling tower. So this is when the plates, the cold water are touched with the hot water, the heat dissipates. So that's how it will work. The additional we install in cooling tower is heat exchangers, plate type heat exchanger, and circulation pumps that can throw the ordinary water or hot water back to cooling tower, because cooling tower is located at the height. This is a typical layout, a typical picture of Cummins genset installed with cooling tower. We have genset, we have a heat exchanger for LT and HT, then we have the pump, we have the cooling tower, and we have the LT and HT expansion tanks. These are the different pictures, cycle of cooling tower, how they installed with the genset. So these are the cooling tower, these are the fans and hot water pipes and cold water pipes. And the light pillow is the cold water, and the black color is the hot water coming from the engines. Then these are the circulation pumps that can throw pump and fresh water and circulate. This is the heat plate type heat exchanger. As I already mentioned that they install close to the genset, so the cooling system remains small. So from here, where your air cooling tower is, circulation water pump can throw and bring the fresh water and hot water from you. The heat exchanger always installed close to the engine, one for LT circuit and one for ST circuit. So these are just an overview of cooling tower installation. And with this one, our coolant circuit is complete. So we have one circuit ST, that is high tension and high temperature. The one is LT, low temperature circuit. Low temperature circuit is only used in afterburner core, while the high temperature circuit is used block, turbochargers, afterburner core, primary side. So these are the installation. We connect. First, we connect rubber or flash connector with the genset. Then we fetch pipe with the wall and pressure gauges and the standards. Take them to cooling towers. If it's a closed circuit, tropical areas. But if it's radiated, if it's cooling tower, then the installation procedure is a bit different. We need to install the plate type heat exchanger. So genset connection will go to plate type heat exchanger or LT1 heat exchanger. So from those heat exchanger, hot and cold water will go to cooling tower through a circulation pump. That will be basics for the cooling system. Let's look at the lubricating oil fill and drain connection with the makeup tank. After cooling, oil is the next customer connection from chemical side. As I already mentioned that the manual or auto filling located on the left bank L2 inspection door, where we have a depth gauge for level check. At the same point, we have manual filling, and we have a Murphy gauge for automatic oil level gauge. This is the makeup tank. The recommendation for the makeup tank should be minimum 1.2 meter height, so the oil can come with gravity. This is the auto filling Murphy gauge that also located on left bank. So the pipe will collect from makeup tank. We now bring a collecting here. So whenever engine oil level is lower, the oil will come with gravity, and auto filling will complete the table. This is the drain point. It is also located on the left bank side. And then we want to drain the oil. We need to use a pump, a external pump, to suck the oil from the sump. So it's both all the oil fill and drain manual and auto fill and drain connection located on the left side of the engine. Gas drain or fuel inlet. Fuel inlet connection is also located at the front side of the engine below under the elevator housing is the 3-inch pipe at the end. 8-hole flange. It's not 4-hole. It's an 8-hole flange line. So this is the same way we already mentioned that all the connection we first use flex connector. This is a flex connector and the FSOV fuel shut-off one. So from here we now select our fuel connections to the gas connections. The customer will complete the lines. Let's have a look at this is the gas drain. After this FSOV, we have the gas drain where we have a pressure regulator, fuel filter, and the valve wall or manual valve. So the connection are where the customer has gas availability, the 3-inch line, and is now connect to this valve. So this is the fuel inlet line, enter to the genset. Then we also have a vent line in case of overpressure. That is normally 1-inch pipeline. So it's mentioned on this gas drain that this is the vent line. So we take a 1-inch pipe from here and release it in the air. In case of pressure regulator stop working or become faulty, the overpressure will evaporate and throw the excess gas into the air. Make sure whenever we are working on the gas lines, it should be authorized personnel routine welding works, so that whenever they do welding, it should be very neat and clean, no pinhole. Then before energize the line, we should perform leakage testing, pressure testing, and X-ray and other required testing according to your territories. Make sure that we must perform all those requirements, testing requirements, before we energize the line with actual fuel. The next one is our last outlet. Exhaust outlet connection. There are gensets supplied with two turbochargers, and two of them has the outlet connection, that is 8-inch flex connector, and 200 bellows. So when we install the bellows should be aligned, must be aligned in axial aligned, so that when our genset running our impression, which will not bend and will not broken. Here are some pictures of exhaust. In the first picture, we can see two turbochargers are connected with an elbow exhaust outlet points. In second picture, we have exhaust bellows. In the third one, I mentioned that it should be axial aligned. Then whenever we use this bellows, this should be cladding so that hot surface will not produce heat around that area. So we have harness and other cables that we not burnt off. Then this is the final picture. We have two exhaust line, then it goes to exhaust port and finally release into the air. Or if you are using CHP, how you can collect the heat from here, take it to your boiler or fan, ablation chillers, or any other device you want to run on heat. In CHP, you can collect heat and reuse. The breather connection, breather outlet is normally a 2.5-inch pipe is located on top of those coolant lines, so where you can now take the engine mostly supplied with the open breather system, where you just release the breathing air into the air. Just connect a pipe and bring it out from the building and collect the fumes inside the bottle or any container. Then the air will release in the air. So that's the breather outlet connection. So with this one, all our mechanical connections has been completed, where we discuss the coolant, LT and ST, in and out. We discuss dual in and out, the valve field and drain. We also discuss coolant vent lines that goes to expansion tank. Then we also discuss fuel line, then exhaust lines and breather lines. So with this one, our mechanical connection has been completed. So let's move on to electrical connections. The electrical installation, the first connections are the load connections, where we connect cables to our load tank. So let's look at where we can collect our load connection. The load connections always collect from alternator terminal. So this is an overview of alternator when we remove the top cover. Here we mentioned that red, yellow, blue and neutral, the transformer and the alternator mostly winded in star connection. So this alternator supplied is also a star connected winding. So we have red, yellow, blue and neutral from here. Then Cummins introduced a connection box. This is a connection box that ties with the alternator cover. Then they provide small short pieces of the cable. This red cable we can see here. So from alternator terminals, the 4 cables come to this terminal box or connection box, from where we now connect our load cables. Let's have a look. From alternator terminals, it comes to power box and it looks like this. Then from here we can now connect our load cables and take them to here we can get the load connection. From alternator terminals, we take them to connection box. Then from connection box, we can now take our final load cables. The load connection mostly will go to a disconnector or circuit breaker. If we are running multiple gensets, it should be a synchronizing breaker. It is also known as synchronizing breaker. If it is a 1 gen, then there should be a protection, either disconnector or breaker, fuses, any type. But mostly with the alternator, we use breakers, motorized breakers, synchronizing breakers. So the connections of the three phases will go separate to breakers. That is also a protection device for your alternator. The alternators are available at 400 voltage, and that is low voltage. It's available at medium voltage. It's available at high voltage, 11 kV, 13.8 kV. So it depends on your own applications. If it's low voltage, we use low voltage cables that goes to low voltage breaker. If it's medium voltage, we use cables as per recommendation and goes to circuit breaker. The template I want to show you is designed for 11 kV. The alternator is designed for 11 kV. That is high voltage. So circuit breaker, known as synchro breaker, is automatically operated electrical switch designed to protect an electrical circuit from damage, either overload, short circuit. So it has safety, it has the protection of relays, a charging mechanism, and different relays, closing, opening, and shunt UVT relays. Then it has disconnector. Then so let's look at tactical view of the breaker. So this is a tactical view of Schneider Geneva breaker. So all this we discuss. We can see them here, their location. Breaker can be supplied by Schneider ABBC, but any your local vendor can provide you breaker. But it should be before we install a breaker, we should look at the specification, whether it meets to the alternator we have. Ampere rating, voltage rating, then some protection. So if the breaker is equipped with that one, we are good to go. This is typical view where we have our load cables from alternator to breaker. One side of the breaker, we install our 3-phase cable, and upper side is the bus bar. From that bus bar, where we can, if we have multiple genset, we install multiple breakers. Then we have outgoing breakers where the customer will install their load cables. Then at LV, the neutral is not an issue. You can just connect the neutral direct to the load. But when it comes to high voltage, either alternator or transformer, the neutral should pass through a neutral arc resistor. If there is any fault, any short circuit, any arc fault on customer end or load end, fault always travel towards source. So before you save the alternator, the current should be in ties. So for that purpose, we use a neutral ground resistance or earthing resistance, that a crucial component in electrical system, damaging to limit the flow of fault currents. It has a resistor, and we can see at this is the resistor. So this is the neutral we have connected. So whenever any fault will come, it will go through the resistor, and this sitting here is a protection. How? It will protect your source. When any current passes through this neutral, this sitting will read the current and tell the relay. So whenever any current passes, then we can setting normal. Those settings are 5% of the rated, 10% of your rated current. Whenever that current passes, the relay will now send signal to your generator for a shutdown. Because whenever that relay detects any value of the ampere and meet up the set point and threshold, it will shut down your engine. And meanwhile, this resistor will magnetize the current. It will produce the short circuit or arc fault current before it travels to the meter, so that our source will remain safe. These are the value calculated from how we can calculate the size of resistor and the city and other. So this is how we can follow it a simple on the I equal to the hand. So how you can collect your value of the register, how when are you design phase. Then if we have multiple generators, the first one is people use separate NER. Then another option is we can buy multi-disconnector or vacuum contactor inside one cubicle. And so we have 4 gensets. So this is the technical magnetic contactor for multiple gensets. We bring all the neutrals. Since we are running in synchronized, all the neutrals are common, so we just connect to one neutral and you're going to want to get. So when any of the current short circuit or current pass through the neutral, the CT will detect, not get your relay. If relay meet up the threshold and the set points, it will not trigger engine. So this is the safety of your source. Normally, this NER used with alternators and transformer on substation. This is our power connections, load connections. Let's look at the auxiliary AC power. In gas generators, and customers supposed to provide auxiliary powers for AC load installed on the gensets, such as there are some circulation pump, and your circulation pump. We have battery chargers. We have heating elements. Then we have motor valves, that is electronic thermostats. So to operate all of them, customers should supply AC power, that is 3-phase and single-phase AC power. This is AC box where we open. So here we connect cables for AC power, that is 3-phase AC power and single-phase AC power. That is the requirement of the genset for operation. When it's standby, it will have heating elements that maintain the heating temperature. So that for quick start, we have circulation pumps, we have battery chargers. Then we also require the AC power to operate our MCC panel. Inside MCC panel, as I mentioned initially, we have ventilation or extractor fans, and if we are using a cooling tower or radiator, we have fans. On those fans, we also need the AC power. So it's customer responsibility to provide those AC powers to run the fans on cooling tower or cooling radiator. Then if our engine is standby, then we need to run heating elements that those maintain the temperature of 55 to 60 degrees centigrade for quick start. This is the auxiliary power. Then let's look at the control system. If we open the GID, then there is the service side, there is the customer side. If you want to read, you have our whole first lecture. Then in coming lecture, we also study about the complete GID. So inside the customer side, we have customer connections, where we now collect and we give inputs and collect outputs. Inside this customer side, if we open the door of the GIB customer side, we have all the connections are labeled. We have bus bar voltage, we have genset current, bus bar current, differential current transformer. We have fuses for auxiliary supplies. We have analog input and output connections. We have load share connections. We have digital output relays. We have input connections. We have CAN communication connection. So this is the details mentioned that what connections are available on these customers. We can collect what we require according to our systems. All the outputs must be required for our site to site. Different site has different requirements. Different plant has different requirements. So we need to look at it, right? What our own requirement, we will collect those connections, and what input we want to apply, you can know. All those inputs are remote start, load demand stop, U20CB in, U20CB out, GCB in, GCB out, open, close, all of them are available in this customer set. So let's have a look. The first stop we have the utility voltage input that is located are labeled with the C0012, C004. We have differential current transformer CTs that labeled with C0052, C010. After this, we have 24-volt DC supplies for external use that is labeled from F36 to F40. We have 24-volt DC in return that is negative supply to C011 to C015. We have output relays from K31 to K50. In these relays, we have these are the outputs. Common warning shutdown, DCB closed, DCB open, utility DCB closed, utility DCB open, genset running. All those available on this output relays. Then we have a remote e-stop. We can want to connect a remote operation parameters. There are connections available labeled with K51. We have CAN communication C016 to C019. We have methane analyzer analog inputs labeled with C020. Then we have the analog input and outputs. These are our load share and all those connections are located here. Then it's located labeled with C021 to C033. We have inputs, remote start, remote stop, remote start, load demand start, customer files, then all those fire protection, differential file, DCB treat, utility DCB treat, DCB position. So all those inputs are labeled to C036, C072. Then equally we have the Ethernet connectors where we can connect our service tools. So let's look at the physical picture of the connections or connectors. So this is the first we discuss. So utility bus, voltage labeled with C001 to C04. This is a utility bus current or differential clamp CTs. This is labeled C06 to 5 to 10. These are the 24-volt external use supply fuses and negative return supplies. This is the CAN bus, CAN A and CAN B. This is the configurable inputs that we mentioned that analog inputs. This is the analog outputs by kilowatt and other, if you can, all of them are configurable too. These are the binary data outputs, K31 to K50 and K51, 31 to K50 are data, such as warning, shutdown, genset CB on and off, U20CB on and off, genset running. K51 is remote emergency stop. Load share lines are located from C31 to C33, 29 and 30 external voltage biasing. C34 and C35 is remote input emergency stop, need for K51 while output. Then remote e-stop is input located at C34, C35. These are the inputs, binary inputs from C0 to 72. All those where we have remote start, load demand stop, customer files, HTLT level tank low, fan trip, radiator fan trip, and earth fault, differential fault, DCB trip, utility DCB trip, genset position. So all the inputs are labeled here where we can connect and use our external. These are the control connections installation process. Now this is the drawing page. If we have the genset drawing, here we can see all the customer connections with labeled. These are the overview, final overview. This is the containerized genset overview. This is how look at it. We have container, we have a glass port and radiator on the top. Genset is inside the container, ventilation are extracted and located inside the enclosure. This is the look when the prayer is open. So we can have the genset, we have the breaker, we have fuel line, we have coolant line, we have radiator on the top, we have a glass port. So this is just overview overlook for an employer type HSK78G genset. We also look at some picture of basic genset installation inside the building. So this is inside the building installation. These are the radiator located outside the building. Just inside the building, we have gensets, and outside the building, we have exhaust ports and cooling radiators. This is another plant where we install HSK78. This is also our basic installation. So these are just some pictures. This is the ventilation system, ventilation fan also shown here. So this is our lecture that give us a glimpse, detailed of HSK78 installation process guidelines. So this is our update sheet. What we have studied, we have shared with you all these green mentioned. Then our next lecture is coming very soon. We do call this lecture in our Cummins tonight. If you have any questions, if you have any information to confirm or to clear this our email ID, just ping us, just write us the email. If you are looking at applying and manual, any recommendations or any service greetings, just write us an email. We are just away of one email. Thank you very much and see you soon with next lecture.